Good morning, guys. Thank you for coming to another home learning session. If you haven't done so already, please complete the retrieval quiz on your student worksheet. So pause the video, come back once you've completed it for the answers. Okay, so the answers for your retrieval quiz. The gas that produces a squeaky pop is hydrogen. The substance that is used to test for carbon dioxide gas is lime water. We use a glowing splint to test for oxygen gas because remember, it will relight the glowing splint. Blue litmus paper will turn white when placed in chlorine gas. The formula for chlorine gas is Cl2, the third one, capital C, lowercase l, 2. 6, remember any group 7 elements form halide ions. Number 7, CO3, -2. Number 8, potassium gives a lilac flame. Number 9, we use barium chloride to test for sulfate ions. And remember, it will form a white precipitate known as barium sulfate. And the test for chlorine gas, you hold blue litmus paper in the sample of gas you're testing, and the paper should go from blue to red, then white. So today we are looking at pure substances and formulations. You might have already heard of these key terms, pure substances and formulations, in previous years. So you need to compare the difference between pure substances and formulations. Now, 3 keywords. If something is pure, it is made of only one type of element or compound. So, for example, pure water is made of just H2O. Pure oxygen is made of just O2 molecules. A mixture is a substance made of more than one element or compound, but they're not chemically bonded. And in a formulation is a type of mixture that has been designed as a useful product. So on the screen in front of you, there's 3 diagrams. One represents an element, one represents a compound, and one represents a mixture. Can you work out which is which? So here we've got particles that are all the same type. If they're all the same type, this one must represent the element. This one is a compound because we've got elements that are chemically joined. And this one on the end must be a mixture because we've got elements and compounds, but they are not chemically bonded. So just to go over the key words, elements. You should already know that elements are substances made from only one type of atom. So for example, gold, if you look on your periodic table in your planners, you can find the symbol for gold. Remember, elements will be found on the periodic table of elements. And remember, gold is an element, so it is made of only one type of atom. And we could draw a particle diagram to demonstrate this. We know that gold at room temperature is a solid, and we know that all the particles are the same type. Oxygen. Find oxygen on your periodic table in group 6. It is an element because it is made of just one type of atom, just oxygen atoms. And mercury, if you look on your periodic table, you'll find the chemical symbol for mercury, and again, it is made up of just one type of atom, mercury atoms. Now, moving on to compounds. Elements can join together to make compounds. So, for example, we can join hydrogen and oxygen together to make water, H2O. We can combine carbon and oxygen together to make carbon dioxide, CO2. So compounds are substances made from two or more different elements chemically bonded or joined together. So you can see in the diagram here of a molecule of water, you've got one oxygen, and the lines between the atoms show a chemical bond with the hydrogen atoms. CO2, carbon dioxide, made of two different elements, carbon and oxygen, joined together. Do you know this one? CH4, methane, well done. And we can see it's a compound because it's made up of more than one type of element chemically bonded. Now a mixture can contain different elements and or compounds that are not chemically bonded. They're not chemically joined, and that's why we can separate mixtures with physical means such as filtration. So you can see here in this diagram, you've got different elements. So you've got this blue molecule here, you've got this red molecule, but you've also got compounds as well within this sample. And that shows me it's a mixture because there's different elements or compounds not chemically joined. So this is, if you look at this diagram here, you can see I've got sodium and chlorine and I've got water. It's soap water. It's a mixture. They're not chemically joined, but they're different elements and compounds. Now, a key example of a mixture is air, the air around us. It's made up of different molecules, different elements, different compounds. So it's got nitrogen, oxygen, and hydrogen in it, water and carbon dioxide that are not chemically joined together. So, for your first task of the lesson, I'd like you to look at the images and decide if each diagram is showing an element, a mixture, or a compound. And I'd like you to explain why you've picked that. So pause the video, go to your student worksheet, complete this task, come back for the answers. So let's go through the answers. So A should have been a mixture because it's got different elements and compounds, not chemically bonded. B should have been an element because there was only one type of atom. C should have been a compound because it's got different types of atoms or elements chemically bonded. D is a mixture because the elements were not chemically bonded. E was an element because, again, it was made of just carbon atoms, one type of atom. F is a compound because there were two different types of atoms chemically joined, chemically bonded. So moving on. In chemistry, a pure substance is just a single element or compound, not mixed with any other substance. A pure substance, so let's talk, for example, of pure water, H2O, nothing else added to it, just H2O. So we know that is pure water because it's got only one compound in that substance. And pure water will have a fixed boiling point. What temperature do you think pure water boils at? 100 degrees, great. So if I wanted to test if a sample of water was pure, I could actually heat it up and find out if it begins to boil at 100 degrees. If it doesn't boil at 100 degrees and it boils at a different temperature, or it begins to boil across a range, for example, a range above 100 degrees, then I know it's not pure water. So, for example, if you add soap to water, you actually increase the boiling point. So, one way of finding out if a substance is pure is to test its boiling point. every pure substance will have a fixed boiling point. And we know water boils at 100 degrees. If our sample doesn't boil at 100 degrees, we know it's not pure water. So one way of finding out if a substance is pure is testing its boiling point. So if you look at the table in the bottom corner of the screen, you can see that we've got the boiling point of water and how the boiling point of water will change by adding sodium chloride, by adding salt. So you can see at 0 grams, the boiling point of water, as we would expect, is 100 degrees. After adding 2 grams of salt, you can see that the boiling point of water has increased. Therefore, we can see it's no longer pure water. And if you look at every time 2 grams of salt is added, the boiling point increases. So, we know what a pure substance is, but have you ever heard of formula milk? I'm sure you all have heard of formula milk. So, what is it? Is it just milk? Why is it called formula milk? So, most infant formulas, so formula milk made for infants, is actually made from cow's milk, which has been processed to make it suitable for babies. But it does not only contain milk. So therefore, it's no longer a pure substance because it's not just pure milk. It's now a mixture. Now, formulations um, have these minerals in them. So infant formula milk isn't just milk, it's got minerals added to help with the baby's growth and development. So we call this a formulation. It's not just a mixture, it's a mixture that has been designed as a useful product, and that is known as a formulation. Now, what you'll notice is that all of these minerals have been added in certain quantities that have been carefully measured and made into a mixture to have a useful desired product at the end. What I'd like you to do is click the link and watch the video. So go to your student worksheet for task 2. I want you to click this link and watch the video on formulations. Okay. So you do need to be able to define what a formulation is. So we know that a formulation is a mixture. We know that that mixture has been specially designed to produce a useful product, such as baby's milk. Formulations are made by mixing the components in measured quantities. So we don't just add loads of different minerals together in the dried cow's milk and mix it all together. It needs to be carefully measured. So, and other examples of formulations where the components have been carefully measured to produce a useful desired product are fuels, paints. Medicines are also an example of formulations, or the components have been carefully measured to make a useful product. Some types of foods are formulations. So there are lots of types of formulations all around us in everyday life. So, task 3 on your student worksheet, I would like you to write a definition for the following keywords, and I would like you to try and give 2 examples of each: an element, a compound, a mixture, and a formulation. Now remember, a formulation is an example of a mixture, but the components have been carefully measured to make a useful product. Pause the video, go and complete this task, come back for your answers. Okay, so remember to make self-corrections from home. That's why I do provide you with the answers on the screen for everything, for you to make self-corrections and progress. So an element, a substance made from one type of atom. Compound, a substance made from two or more different atoms or elements. You can use either word, chemically bonded or chemically joined. Mixture is a substance made from different elements and or compounds that are not chemically bonded. And then a formulation is a mixture of carefully measured components to make a useful product. Now that leads us on to the consolidation part for the lesson. What I'd like you to do is there are 10 statements on your student worksheet. Each sentence is describing a keyword from today. So either element, compound, mixture, pure substance, or formulation. You need to decide which keyword is being described. So pause this lesson video, complete your consolidation, come back for your answers. Okay, so let's look at the answers. Compound is the first one. Number 2, if it's made from one type of atom, it must be an element. Number 3, if it's got an exact boiling point, it must be a pure substance. Number 4, if it does not have a fixed boiling point, it must be a mixture. Soap water is an example of a mixture. Elements are found on the periodic table. Number 7, mixtures are not chemically bonded. Number 8, paint is an example of a mixture, but is a special type of mixture known as a formulation. Number 9, this has been made by mixing precise quantities together. Formulation. Number 10, pure substance. Okay, so that brings us on to the learning intention and our RAG rating for our understanding of the learning intention. So that was to compare pure substances and formulations. So are you red, amber, or green? Once you've completed your RAG rating, submit your work. I look forward to seeing them. Thank you very much, guys.